So I generate a new file, and my objective is to write the functions for Weibull distribution. Right? There are about 6 types of Weibull distributions available in SciPy statistics, but I think mm, those are slightly different than the Weibull distribution we require. So at first, I give here a title. So first cell as a markdown. In the markdown, we can write the titles, we can write equations. Some of you might have seen in my demonstrations. So markdown, it is for Weibull distribution. So when I execute, it will become Weibull distribution. And that is the use of notebooks, that it provides you a facility to on the go develop your notes, and you can add figures to that and like everything there. Okay. So I import the library, import numpy, and import type dot, well that is not required, import mat dot lib dot py dot splt. I'm not going to call any function from SciPy. I'm going to write my own function. In the next cell, let's define. We write the keyword define. So define the function name. I write for density function, Weibull function, and so it is going to get the value of t, right? And there should be one beta value and alpha value, right? And what it should return, that should be the expression beta divided by alpha raised to the power beta times t raised to the power beta minus 1, right? Times numpy exponential function exp of t over alpha, and this is to the power beta, and that's it. So this is one function. This is the density function. Okay, well that was missing, so there should be a negative sign, right? This is for the density function f of t, right? Small f of t. It is for density function, right? And the next function that I like to define, that will be define the PDF CDF function, right? So I call it as cumulative function C define. Okay, define C Weibull. So T beta alpha, it should return value 1 minus numpy exponential function of minus t over alpha, and raised to the power beta. And that's it. Now let's test these two functions, right? So these functions have been identified by the program. Now let's define a vector t. So t vector, I define num by linear space, say from 0 to 10 in steps of in say 50 steps, right? And we require the value of alpha, say value of alpha 0.3 and beta value equal to alpha equal to 3 and beta value say 0.4, right? And now let's plot, right? LT dot plot, and I say, and I call D Weibull T alpha, sorry, I wrote beta for beta alpha, right? And plot it with R line. And on the same graph, okay, so this is the function, and then the attribute red line, and on similar plot, I plot C Weibull T beta and alpha, right? And plot it as blue line, right? I should give legends to the plot. So my first plot is the f of t, right? And the second plot refers to of t, right? So these will be the legends to identify the two curves. There are two curves on okay, and then PLT show, right? So let's see the working of this program segment. So many errors have been returned. PLT legend. Okay, we have got one graph, blue line has appeared. Weibull T beta alpha PLT. Okay, it should be again try. There is a problem with the legend. So let's only see what. So one plot has been developed, but for the other we have some problem. Let's see the function, density function. It was a bit tricky. Beta over alpha raised to the power beta, right? Times t. Alpha raised to the power beta. Yes. So let's write it a bit more cautiously. T raised to the power beta minus 1. There was the problem that this negative sign should be like this, right? Okay, so that's the Weibull distribution, and we have known it is it is going to change its shape as the value of beta is positive or negative, right? So for negative value 0.4, so we have different type of behavior, right? And it is also important whether we should use the fractional value or the value like this, whole number value. So you have shape parameter. I have only changed the values of beta, right? Okay, so C divided by 0 and counted in power. So some warning has appeared. Maybe it is not very nicely defined at t equal to 0. No, it is not really a big problem. Okay. That's the nicer one, right? So density function and the distribution function, right? Now let's see the legend command. Legend. Okay. So legend command was also, so that is something, the appearance of errors, uh, which really a kind of confusion for a person writing live programs in the classes, right? Therefore, I usually say my experiments are much serious experiments and dangerous experiments than the experiments Professor Waterloo would use to perform in his classes. So see the legends, they have appeared. We have two curves, so they must be distinguished with the legend, and there should be titles. How to give titles? So PLT, we say X label. So it is time, right? And you should provide the units, say hours or years, and PLT I label, and it is the probability, right? Probability functions, right? So in Python, also in labels, you can you can provide the mathematical symbols like theta, alpha, beta. That is also possible, right? So please explore that thing. So with this demonstration, my objective was to say that if some function is not available, but you have the mathematical expression for density function and distribution function, so you can write your own function to calculate those things. So these are very simple demonstrations for functions. So actually, the error was with this negative sign. So generally, the exponential should be the decreasing one. When it was written inside this parenthesis, then it became positive. So it became something exploding